Let's get started. Swift. It's Apple's new programming language, introduced during last year's WWDC, and is aimed to hopefully kind of replace Objective-C sometime in the future. What is Swift? It's a very powerful language, actually. It has lots of new modern things we expect from a modern language, and it's actually very easy to use. And during this presentation, I will teach you and show you some of its syntax, how it looks, what you can do with it. I will also take a little bit more time to take a look at optionals. Optionals is something introduced in Swift that causes lots of confusion for people, and I hope to be able to make it very clear about how those work. I will also show you a little bit about how you can mix and use Swift together with Objective-C, either in existing projects or in new projects where you would like to have Objective-C as well. And at the end, I will show you a new feature called Playgrounds that got introduced with Swift, where you can actually run Swift like a script language, and I'll demo it a little bit as well. Yeah, as I said before, what is Swift? Swift is modern. It's, as I said before, it is a static and strong language compared to Objective-C, which is kind of dynamic in its nature. Swift is very, very strict about what stuff you can do and what you can't do. It will not allow you to be completely dynamic about types. You have to be very specific about what you want. It is inferred. That means that you don't always have to explicitly type out what kind of type you want to use. Swift can figure out by itself what you mean a lot of the times. And it's safer. They have brought in a lot of new stuff that makes it a little bit safer than a lot of us are used to in Objective-C. For example, they enforce curly braces on if statements, so you cannot do any stupid go to fail, as Apple did in their own source code. And it also introduces some overflow securities as well to protect from those kind of errors. Swift is very fast and very powerful. Well, the fast bit is not really there yet, but it's coming. They're continuously improving their compiler to make it very, very fast. And it actually compiles to native code, to machine code, so there's no virtual machine involved at all, no garbage collection that runs and takes up precious CPU cycles. So, what are some of the differences compared to Objective-C? Well, first of all, there's no need for header files, which is a welcome thing, at least according to me. Everything kind of just is automatically imported to you. We don't need the semicolon anymore. You are allowed to use it if you want, but there's no requirement for it. It introduces the concept of generic programming, which is very common in a lot of other languages, such as C#. And the functions in Swift are first-class objects, so they can be used anywhere an object would be used, which is very, very handy. And something that a lot of other languages as well has had for a while. People writing in JavaScript will be very familiar with this concept. And pointers are not exposed by default, so no more stars everywhere, as in Objective-C. It makes it a little bit cleaner, a lot more safer, and hopefully, in the end, faster as well. So let's get started. Let's jump straight in. Take a look at variables and constants. This is how you define a variable in Swift. So first you have the var keyword, which is very common from languages like JavaScript or C#. And then you have the name. And in this case, you have a colon int. That makes it very clear that this is an integer. nothing else. And in this case, we have assigned a value to it. If you want to make a constant, it is now very easy compared to what it was like in Obj-C, where you had to figure out with all these const keywords and place them in the right order, and people don't remember how to do them, so they have to Google them every time. So now we have this let keyword. It's very, very simple, and Apple encourages you to use let everywhere, unless it actually has to be a variable. And not only does that help the programmer and your colleagues to tell you what values we expect to change and what values we expect not to change, but it also helps the compiler figure out what will and what will not change, so it can be even more aggressive when it compiles and produce even faster running code. But this can be written shorter. We can make this much shorter. We don't even have to be specific about the types. Swift can infer that. So we can only write var age 26, and it'll figure out that's an int, and it'll figure out that the second row is a string. Next up, arrays. It's very simple to use to define arrays in Swift. This looks very much like the syntax we're used to from Obj-C with the literals, where you can just define them as this. If you want to access values in it, you can do it just as you're used to with indexes. And if you want to create an empty new array, you do that by placing the type of value you want to create an array for inside these square brackets and finish off with parentheses. And Swift, compared to Obj-C, is actually strict about types in collections. In Obj-C, you can store anything in an answer array. In Swift, you have to be specific about what you want to store, and that makes it very, very safe to use, and very easy because the autocompletion is much more powerful now than it was before. Arrays are in Swift value types, so they're not referenced when you pass them around. They're actually copied, and that's a good thing to know when working with them. So if you want to make a mutable array, how do you do that? Well, it's very simple. Just change out the let for a var, and that implies it's mutable. And now you can add stuff to it by using the append keyword. You can actually use the literal thing with square brackets as well, and add at specific indexes and change stuff. It's very, very simple. Taking a look at dictionaries, they too look very, very similar to what we used to in Obj-C. Just square brackets, no more @ signs, just put them in there. And again, very easy to access, very easy to create new ones that are empty. Exactly like in arrays, you just specify what types you want, and this time you just put two types with a colon in between. Dictionaries work the exact same way as arrays when it comes to mutability. If you want a mutable array, create it as a var. And if you want an immutable array, create it as a let, as a constant. And they too are value types. Moving on to strings. Strings in Swift are fully Unicode compliant. You can store anything in it, like this little party Unicode character. And this beer Unicode character. And here we can see the same principle as I've told you about before with var and let. The second row here is actually a mutable string. You can add stuff to it, so you can create a beer party. Strings are also value types in Swift. Now let's take a look at what more we can do with strings. Looping over characters in Swift is really easy. It reminds us a lot about what it looks like in Python. You just create a for-in loop and loop over each and every character in a string. Very easy, super powerful. And one more thing about strings, string interpolation. So let's say we want to create a sentence out of this. We want to say, for example, Petar is X months old. We can do that with string interpolation. It looks like this. So you pretty much define your string, and in parentheses with a backslash before it, you put your expression. In this example, we put in the name first, and the second time we do it, you can actually see we're using expressions. This is very powerful and very easy to read, actually. I love this syntax. Much more clear to see what we want to do than using a string format type syntax that we're used to from a lot of other languages. And this just creates this string. Now moving on to functions or closures. They're kind of the same thing. Functions are named closures, or closures are anonymous functions. Depends on how you want to look at it. This is a very simple function. It just prints out the word hello, and it has no return type, no parameters, so it's very, very short and concise. That makes Swift very, very readable when you have lots of code. You don't have to read all those void stuff that you're not interested in. And if you want to invoke it, just as you're used to, just finish off with a parentheses and the name of the name. And what does it look like if you want to have some parameters? Just put them inside the parentheses like we're used to. The difference being, compared to other languages as we're used to in Swift, name first and then colon the type. In this case, we cannot infer the type because this is actually the definition. So we have to have the type here. And here we can see another example of string interpolation. Very simple, very elegant. But this doesn't return anything. What if you want to have a return type? We add that at the end with this little pointer arrow and the type we want to return. Everything else is just like we're used to. Invoke it with our parameters and you get something back. There's no magic here. So closures. Here's an example of a closure. It is this thing between the curly brackets. And as I said, closures are like anonymous functions, or functions are named closures. In this case, we assign it to the variable hello world. If we take a look at what it actually looks like, this is what it looks like. So we have parentheses, arrow, parentheses. It's very similar to what I showed you just now with functions. See that here? Our arrow things? Except that in this case, you don't have to have the last one because it's inferred to be void. An empty parenthesis is void in Swift. And if you want to invoke any of them, just type hello world and parentheses. Works for both of these examples. We can also use closures as parameters, and that goes for functions as well, actually. So let's say we have this function called repeat. It takes a count, the number of times we want to repeat a certain task, and a task, which is a closure that takes no parameters and returns no values. What can we do with this? First of all, let's put in a for in loop. We want to loop it over count number of times. So we have this little for syntax here. Goes from 0 to count, but not into count. If you want to include count, you put 3 dots instead of that pointer thing. Inside that, we put our task closure that we entered. And now we got this function that takes a closure. So how do we use this? Type out, just as we were used to. Repeat 5 times. We want to repeat this 5 times. And then we have this curly bracelet syntax to put in some closures. In it we have the closures, what's it called? The closures what it looks like. I don't remember the word right now. I'm sorry. And then we'll finish off with what we actually wanted to do after the in keyword. But as I told you before, Swift is very good at inferring types for us. So we can actually make this shorter. In this case, we don't have any parameters nor any return types, so we can just remove that altogether and just keep the parentheses and the curly braces. But this can actually be a little bit more elegant, and we can actually move the last parentheses on the last row up and replace the comma over there. Now it looks like a control statement, and it actually kind of is. And it's very, very easy to read and understand what this does. Repeat 5 times what's inside this code block. Very, very clear. I love that syntax. And I use it all the time. What I love about closures in Swift compared to Objective-C, in Objective-C, you had to type them if you wanted to use them, if you wanted to create your own. And it was kind of, complicated, and you didn't always remember the syntax. You had to Google it, just because you used it so infrequent.
If you have a function with the same
signature
as the closure, can you just send that in instead of writing?
Yeah, you can do that. As I said before, the functions and closures are pretty much the same thing. Anonymous functions or named closures, depending on how you want to look at it. So it's very, very powerful and very similar to JavaScript and other languages that have the same kind of principles. In this case, we have a list, an array of a couple of numbers. They're not ordered, so we want to fix that. So let's sort them with this sort function. And this sort function takes a closure where you input the first and the second object and compare them and return a bool, whether the first value is larger than the second one. And in this case, we just make it a very, very simple statement, return if the first number is smaller than the second number. But as I said before, we can infer a lot of these things here. Yeah, this is the results. So we can infer, first of all, we don't have to have the return type on the closure. That's completely unnecessary. Swift knows about that. We don't really care about that. We can actually also remove the return statement because Swift can infer that the last line in the closure is the return statement if it returns something. We can actually go even further than this. We can actually remove the entire definition of the closure. And in this case, we don't have any parameter names, so we just use index-based parameters with a $sign and 0. It becomes very, very simple. I might not recommend using this syntax all the time, because a lot of times you might want to know what kind of stuff you're working with. But in sort example, it's the first versus the second object. It's very, very clear. So we don't actually need to name them. We would actually just name them first value or second value anyway. And in this particular case, and in some other cases as well, we can actually make this even shorter by just putting what we want to do in which order inside of parentheses. It becomes really, really simple and really easy to read. I love this. It's great. So, as I said before, just to summarize the closures a little bit, we can use them as parameters. They are first-class citizens, first-class objects. We can use them as return types, and we can assign them to variables and constants. And if we do, we can just evaluate them just as functions. Just call that variable with a parenthesis at the end, and you'll invoke the closure. Really powerful and really simple. Next, just a quickie about switch statements, which are much improved in Swift compared to Objective-C. In this case, we want to switch on wheel count. We have some kind of vehicle, with X number of wheels, and we want to identify that vehicle. So if we have 2 wheels, it's a bike. If we have 4 wheels, it's a car. If it has between 6 and 18 wheels, it's a truck. In this case, it doesn't go up to 17, it actually includes 18. In Swift, switch statements must be exhaustive. So you have to cover all possible alternatives. And that's for safety, so you don't forget anything. And in this case, we can use the default, because otherwise we would have a very long list of all integers, or use very, very long ranges. Another thing that's very nice in Swift, I don't know if you've noticed, we don't have any break statements here. And that's because in Swift, switch statements don't automatically fall through. Instead, if you want them to fall through, you have to be explicit about that. And that's very nice because, according to me, this is the most common use case, not to fall through. But switch statements in Swift are even more powerful than this, because we can actually switch on anything, not just integers and enums. In this case, I'm switching on strings. And again, I have to use the default, because otherwise I would have a shit long list of possible strings to switch on. Pretty much endless. Let's talk a little bit about classes, structs, and enums. In Swift, they are very much alike. In Objective-C, they were very different in a lot of ways. Enums were very, very constricted to what they could do. Couldn't do a lot. Same thing with structs, very primitive. And the classes had all the power. In Swift, that's not the case. In Swift, they are very much alike and can do a lot of things, as you can see, as you will see soon. First, let's talk about structs. Structs can actually inherit from stuff. From protocols, actually. Not from other structs or other classes, but from protocols. Which makes it very powerful. So you can use this polymorphism thing in object-oriented programming together with structs as well. And you can implement protocols that are defined in the Cocoa, like enums copying, for example. Like we used to, we have properties or values on structs. In this case, we have a default value of 4. And in Swift, structs can have functions as well, and initializers. This makes it immensely powerful. And if you define a function in a struct that actually changes one of the properties, you have to add this little keyword mutating before, just to make it clear what you're doing. And structs, just like arrays and strings and dictionaries, become immutable if they're stored in a let constant. So it's very easy to use this immutability thing just by defining it in a let constant when you use them. And they're stored as value types, so they're copied every time you use them, which as well is very powerful if you know what you're doing.
If you store this in a let, can you then call the function and change the number of wheels?
No, in this case you cannot, because it's constant, and that's the difference between a class and a struct. Because in a class you could actually do that. You could, in a class, if you define it as a let, as a constant, the only thing that would that's going to constrain you is that you cannot redefine that particular.
You can't reassign it to the variable.
Exactly. You can manipulate the object itself. In a struct, you can't do that. And it makes it very, very powerful if you want to use immutability a lot of the times. Going over to enums. Enums, very simple to define. In this case, we have a vehicle type of boat and a car. Enums 2 are value types, and enums 2 will become constant if you define them as a let, and you cannot mutate them or their type, properties inside. Enums in Swift are even more powerful, just like the switch statements. You can actually type the enum to a string or any other object, just as switch statements. In Obj-C, we were constricted to primitive types such as int. This isn't the case anymore. This is much more powerful. But it doesn't stop there. We can go further. We can store values in cases. For example, we can store the make of that car that we're storing. And if we take a look at how we create one of those, so we have a constant vehicle type, of type car, and of the make Tesla in this case. And then we can just switch on that, take a look at, is it a car or is it a boat? And if it's a car, we can take a look at what make that is. This is very powerful. Let's take a look at what that could look like used. So we have a switch statement. We want to switch on this particular vehicle type. And we have the case boat. And here again, Swift is inferring the type for us. So we don't have to type vehicle type dot boat. It's enough with the dot boat. Makes it very clear, especially when you have long types. And then you can switch on the car type as well. And here you just create a variable to store the make in that you can use inside the case. And as you can see here, we don't have a default in this case because the enum only has two values and we've covered both of them, so we don't have to have a default. As I said before, enums must be exhaustive in Swift. It won't allow you not to have them exhaustive. You have to do that.
Can you not print the actual enum in both? Since it's a string.
Yes, you could do that. You could print the type. You mean the
Yeah.
car type?
Yeah, especially the boat type.
Yeah.
We can print both there.
Yeah, you mean instead of having a constant string there. Yeah, you could do that. You could actually access the type name. And enums can also have functions, just like structs and classes. And they too have to have this mutating keyword if they change a value inside the enum. And that's used because Swift wants to know what changes values inside and what doesn't, so it can help us when we define it as constants with the let keyword. And just to summarize, structs, enums, and classes. Classes are reference types, and structs and enums are value types, which means they're pretty much copied when you pass them around. Classes are not. Classes have inheritance from other classes. We can actually inherit from other Obj-C classes as well. And the other way around, you can inherit from Swift classes in Obj-C. We'll talk more about that later. All three can inherit from protocols. So you can inherit from protocols and use polymorphism, which is very, very nice. All three can have methods. That includes initializers, which is a special type of method, basically. And enums can have associated values, as I showed you just now with the car that had a make. Moving on. Optionals. What are they? And how do we use them? So let's say we have a property named wheels. It has to have a value, and in this case we set it to 0. But we don't want to have a value for it. We want to have no value at all. And in Obj-C, what you would do is probably set a magic value like max int or min int as there exists no value, just like the ns not found constant available. So, but in Swift you don't have to do that. You can just add this question mark at the end. And that makes this an optional. And that means that this value can be nil as well. It can have no value at all. But nil in this case is not 0 as it would be in Objective-C. It would actually mean there's no value. So let's take a look at how we could use this. Let's say we have an optional int named wheels, and we want to take a look. Does wheels contain anything? Is it nil? Yes, it is. Then it's not set. If we have something in it, we can print that. And because wheels is an optional, we have to add this little exclamation mark at the end here. And that just means that we're unwrapping the optional to take a look at the value inside it. But this isn't very pretty. This is very complicated. And we can actually simplify this a lot. And they've introduced this if-let syntax. So what you do is you define a constant inside an if statement where you assign the value from the optional. And what happens is, if we have a value on wheels, if it is not nil, if we have, for example, 5, then num wheels will be set to 5 and be a non-optional int. And in that case, we don't have to use this little exclamation mark that unwraps the whole optional. And if it's nil, it will just go down to the else statement. It becomes much more cleaner than the other case, especially since you don't have to use the exclamation mark.
Just one comment here.
Yeah.
So here actually we can use if that wheels equal to wheels. So that means we can reuse the same variable name. Because when you write applications, so sometimes, at least for me, I just run out of ideas what a new name can be. So if you use the same name, so Swift is smart enough to figure out that here wheels is a real value. It's no longer optional. So that can be handy.
Thanks. Moving on to the next thing about optionals. Optional chaining. So let's say in a class we have a delegate, and the delegate is optional. We might have it, we might not have it, we don't know. And that delegate implements a protocol which has an optional function defined called update value. So we might have this delegate, and this delegate might have this update value. We don't know. In this case, we can just use question marks at the end. And if the delegate is nil, if it's not set, the result will be nil, and it will just stop evaluating. And if it doesn't have the update value, it again will just stop evaluating and return nil. It becomes so clear instead of having if statements to check if the delegate is set. Even if we're using the new if-let syntax to do that, this becomes much more clear. And then we don't have to use reflection to detect whether the delegate implements this method or not. We can just put a question mark at the end, and if it does, it'll get evaluated. One thing to note about optionals is that they're enums. This is very good to know. So this is what they look like actually. It's an optional of type T, and this is generic programming. Those who are familiar with it will recognize this syntax. And in this case, the optional can be either none or some. And if it's some, it actually has an associated value of the type T. So for example, if you have an optional of int, it can either be none or that int that we put inside. And a good thing to remember about this is that optionals are types. They're not just something magical. They're actually types. And the question marks and the exclamation mark are just syntactic sugar to make them easier to use. So let's take a look at unwrapping again. So let's say we have an optional. We want to have this as an optional, but we want to assign it a default value because at some point later we might set it to nil. And in that case, we can use this question mark there. And when we use it, you just use the exclamation mark to unwrap it. In this case, we're very certain that we will always have a value, and that's perfectly legal to do. We can actually also move that exclamation mark up there. And what happens is that every time we use age, it'll be unwrapped for us. But be careful, if it is actually nil and you use it, it's going to crash. Let's take a look at default values for optionals. A lot of you will probably be familiar with this if syntax, where you put the statement first, question mark, this true statement and the false statement. And this looks very cluttery, not very nice. And Swift makes this a little bit nicer by introducing this question mark syntax. So if age is set to something, it'll return that. If it's nil, we return the default value. In this case, we've used 0. We can use something else. So just to summarize optionals, it's a type. Remember that. The optional itself, it's a type, and it contains a value or it doesn't contain a value. And if it has a value, it's of a specific type that's defined. Or it's nil. Let's take a little bit more look on classes, structs, and enums, and what they all can have. They can all have properties. They can all have initializers, calculated properties, which is pretty much a nicer way of typing functions that return a certain value, and another function that sets that same value, if you want to have a set calculated property. We can have lazy properties, and that's very nice if you have something that's heavy that you want to initialize at a later time. You can just put the keyword lazy in front of it, and that'll work. We can have property observers, which we'll take a closer look at shortly. And we can have extensions, which I'll also talk a little bit more about. Let's start with initializers. Let's say we have this class of person with age and name. This is what an initializer looks like. So it's very, very similar to functions, except that it doesn't have an explicit name. And we don't use the func keyword, we just use the init keyword. Classes that have properties that are not optional must be set during initialization, either by default values or in the initializers. That's very, very important. And actually, Swift will not compile if it's not set properly. A thing to remember about initializers, though, we have this designator initializer thing, and we have convenience initializers. I'm not going to go deeper into those. You can read all about that on the documentation online. There are some strict rules about what is what and when to use what. One thing to know, though, is that we can use initializers on structs and enums as well. Structs, for example, get an automatic initializer. In this case, we don't have an optional name or a age, but we get an automatic initializer containing both properties, which is very nice. We can override that if we want, but we get it for free. Let's look at property observers. So let's say you have an age of a person, and when that age gets changed, we want to get notified about that. We can do that with this didSet keyword. And then we can take a look and see if the age increased on this particular person, and if it does, we can celebrate him. It's as simple as that. And there's also another one called willSet. The difference between them is that the willSet will be called before the property is actually changed, and the didSet after. And when we use didSet, we have this old value variable accessible to us, so we can see what the old value was. And if we called will set, we get a variable named new value. So you can compare those to what we're actually setting. Extensions. They're much like categories in Objective-C. You have a class either written by yourself or some other one. Maybe it's even closed, so you don't have the source code to it. You can't change it. With extensions, you can add your own methods, your own calculated properties, and make it more powerful. And the really good thing about extensions compared to Objective-C is that you don't have to name them anything. You can just tell Swift which class we want to extend. And they automatically get will become available everywhere, because we don't have to import header files as we do in Objective-C. So this becomes much more powerful than in Objective-C, where if you wrote a category, you actually had to import it to use it. In Swift, you don't. So in this case, I'm just adding a calculator property on the string, where you can do this Swedish thing, rövarspråket, on the string itself. And in this case, this is a calculator property that just has a getter, doesn't have a setter, and then we don't have to specify that we're using a getter. Just add a closure at the end, and using it is as simple as that. Let's talk a little bit about tuples. That's another new thing in Swift. It's available in other languages, not in Objective-C. It basically just is multiple values put together into one. You could almost say anonymous objects, not really, because they don't have methods and stuff, but you can just group together a couple of values like this, a string and an int. You can assign them to a variable or a constant, and if you want to access them, you can access them by their index. Or what you could do is you can actually name them, and then you can access them by name. What you could also do is this. You could kind of much put a tuple as the variable or constant itself, and then just access those variables. Very, very clean. And
Can have a value as a function itself. Tuple of function.
Yeah. So you can put in functions there. You can return them, use them as parameters. You can use them as properties. It's very powerful. They are first-class citizens, just like functions and all other properties in Swift. Let's talk a little bit about how we can use this together with our probably existing Objective-C code. Good thing to know is that it works almost flawlessly. There are a couple of things that we need to know. It's very, very well integrated with Cocoa and Apple's frameworks. There are some limitations though. One thing to know is that you can inherit from Objective-C into Swift and from Swift into Objective-C. Again, limitations to that. So, if we want to use Objective-C code into Swift, first of all, we need to have a bridging header. And that's pretty much just a header where we import all our Objective-C code that we want to use in Swift. Because as I said, in Swift, we don't have to import stuff. But when we're using Objective-C code, we do. Although not in every Swift file, we have this common bridging header for the entire project. If we're using Swift code in Objective-C, we have this Swift module that's being set up in the project that you can include in your Objective-C code and access all your Swift code from there. To access Swift code in Objective-C, you have to add this @Objective-C attribute to the class or property or enum. And a thing to remember is that Swift is much more powerful, so these concepts of tuples and enums that aren't integers are not available in Objective-C, so you cannot export like an enum containing a string into Objective-C. But the compiler will just warn you about that, so just go ahead and try it. And if you want to use this bridging header, easiest thing to do is to add a Swift file to an existing Objective-C project or our Objective-C file to an existing Swift project. And Xcode will automatically ask you if you want to have this Objective-C bridging header set up for you. Just click yes. Otherwise, you're going to have to do it yourself later, which is not hard at all. Just create an empty header file. Looks just like this. Just include your stuff. And in your project settings, there's a property there called Objective-C bridging header. You just specify this file and you're set. So in this case, I imported my Foo Objective-C class, and now I can just use it in Swift just like that. Simple, elegant. And if you want to use Swift classes in Objective-C, as I said, we need to use that @Objective-C attribute, and then we can just use it after importing the Frukost Seminarium -swift.h file. And the name of that file is your project's name -swift. You can change that. There's a module setting in project settings. Very, very simple. And going over to playgrounds. Oh, that wasn't very sharp. This is a new thing Apple introduced during WWDC. It's a very simple text editor that you can launch in your Xcode. And there you can just type in your Swift code and it will be evaluated as you type live. And you can actually see all the values and everything as graphs, as graphics, as you type. It's very, very powerful, very easy to use. And I see I'm going a little bit over time, so I'll leave the demo to the end for people who want to stay behind and jump straight over to the summary. So what we've gone through is the basic syntax of this stuff, how it looks like, how we define constants and variables, arrays, strings, some new features, for example, that we can use any kind of type for an enum, associated values for enums. We have this more powerful switch statements, we have tuples, we have closures. They are actually available kind of in Objective-C, but the syntax is kind of ugly. We've gone through optionals, how they work. If anybody didn't quite get that, I'm all ears afterwards and I can try to explain it further. And I've gone through how to mix Objective-C and Swift. Unfortunately, this talk has to end. It cannot be infinite. There's almost an infinite amount of topics we can talk about when it comes to Swift. So if you want to learn more, I recommend searching on Swift on iBooks. There's a couple of free books there from Apple that goes through the language itself. I can recommend the Swift documentation itself, which is very well written. According to me, the best documentation there is. Apple is really good at this. You can read the official Swift blog. Apple is becoming a more open company, and they actually have an official Swift blog where they write entries and stuff about what's new. On iTunes University, there is this course called Stanford CS193P. It's a free course you can attend. Unfortunately, you won't get a diploma unless you attend in person and apply for Stanford. But you can look at all the videos and all the materials on iTunes, and it's free. It's really, really good. The guy holding it does that every year. This year is the first year with Swift, of course. And he's very, very competent. I recommend that especially. I myself am getting a little bit hungry, and I guess some of you are too. So I'm going to thank you all for coming. And we can take a look at the playgrounds and the demo after we eat or during eating if you want to.